So what we'll do first is we are going to go over our course information, and then the expectation of the course, what you will be learning, and then we will get into more of the technical concept. I like to go over like a little bit of Q&A so that way I can give you the technical concept, and then the last part is we will start working on the lab. I like to write my lab to correlate with whatever you're learning. So that way, and then how that's applied in the field, we'll talk about that. But we'll just go over the administrative parts now for day one. But from here on out in week 2, we'll start with lecture and then we'll get into the technical exercises so you can see. Welcome to CIS-40A. I see some familiar faces. Some of you have taken my classes before, possibly for security class or other classes like forensic or ethical hacking. This is a class that really entails objectives for Network Plus. I know some of you are on track for the IT specialist certificate or the associate degree. This class is really essential for cybersecurity students because, 80–90% of your work is going to be related to networks. So the more you are well versed with networks, the better it's going to be for you, right? A little bit about myself. I started at Moreno Valley College in 2018. Prior to that, I taught for College of the Desert in private schools. I've been in the industry for a long time. I currently consult 7 clients who own medical facilities across the nation, some local, some in another state. My role in this area is to be able to look at their security practices, give their technical team or contracted companies that they've used for the IT part advice on how to improve. I am a full-time faculty here, and I built out the cybersecurity, the IT program, along with the apprenticeship for Moreno Valley College. And I've been teaching now over 20 years. I started in 2005, right? And so teaching for me is fun. I enjoy teaching the technical area, and I teach in computer science, data science, programming, along with IT and cybersecurity. Okay, so for this class, you are going to learn the concepts that will be related to Network Plus. We're going to talk a little bit about how that's different from CCNA for those of you who are interested in taking CCNA down the line. So the course description, as it's shown, the jobs that you're going to see, especially in networking, is going to really address the local area network, the wide area network, and we'll touch on that, along with the protocols or that would be related to the services. So protocols are rules that the system use to be able to communicate, just like how you have rules in your household, right? There might be curfew growing up, or certain tasks that you do, so that way you can be part of that family. So the system would have services that would have rules that have been established in the industry, like web, HTTP, right? And we're gonna talk about these protocols that relate to the services. Now, on the security side, that's really important because sometimes we are required to use a certain services like web application, but that creates issues if we don't protect our system accordingly. So we'll take a look at how we can better improve our landscape and security through networks. We're going to meet once a week, and I'm going to try to give you hands-on along with the concept while you're here. You can also contact me in case you have questions, or if you need help. I have office hours on Thursday. They canceled my Thursday night class, so I was in here last night helping one of my forensic students. So I would come to this room about 4 o'clock, a little bit after 4, because there's a class exiting. And so in case you need to make up work, right, and you need to use the system Thursday evening, right, or late afternoon will probably be best. I try to come to class early on Friday because they're not using this room. So if you want to catch up on work or have questions, you can come in a little early as well. Okay, so we're gonna meet in here from 1:30 to 4:50. And we're gonna use Canvas to access our assignments and our weekly tasks along with quiz and exam. And in this class, the content is really gonna entail a lot of acronyms and terminology. Some of you are familiar with this as you have taken maybe CIS-40A or other network or security classes, and it might be reviewed for you. But some of you will be new in this area, and I would encourage you to review, right? It's hard to remember these terminology and all the technologies, but as you use it more, right, it's gonna be better. Network Plus, it is a harder certification compared to Security Plus. Maybe equivalent to A plus, but A plus have two parts. The reason why is just there's so many components within Network Plus, but students have passed it with high flying color in my experience after taking the class. So I would encourage you to work toward that goal. So by the end, even before the class ends, right, if you're a Moreno Valley College student, email me and I'll give you a voucher to take the test. And that voucher normally goes for $350. So it'll save you some money. And then if you're on the apprenticeship track, right, employers look at that positively. I read recently during the summer, I had a little bit of time to look at LinkedIn and how the companies are hiring interns or even entry-level IT or cybersecurity position. Now they are demanding more certifications. So the more you have stacked, right, while you're in school and while you're doing apprenticeship, getting your work experience by the time you get your bachelor degree, you're ready and you can leverage your salary that way. But if you wait, right, the longer you wait, the longer it's gonna take for you to acquire work experience and get the jobs that you want. So, okay. So for the content, we're gonna talk about OSI layers. This is critical in Network Plus and CCNA. It is basically a model that they use to be able to really establish system communication from the time that your computer or your smartphone sends signal, right, to its wireless adapter, or could be a network adapter, and how it communicates through the wire, right, or over the air, and it reaches the destination. So even when you're making a phone call on your smartphone, right, or accessing your email, so we'll touch on OSI layers. And the more you're familiar with the layer, the easier it is, because in security, when we're looking at risk, we are looking at specific layer, like application layer, or when things are sent, right, from your system to the rest of the network. I just did a forensic malware analysis class, like on Wednesday, right, when we were looking at network traffic and how the malware was coming in from that, and be able to understand, like, you know, where it's coming from, which computer downloaded it, etc. So OSI is important in networking and also in security. For TCP/IP, all the jobs that you see for networking, it's gonna say ability to manage, you know, a LAN or a WAN. You know, TCP/IP is the technology that we're using now. So we'll look specifically at the protocol, and under TCP, there are other protocols. It's like a family of protocols, the rules. And IP is specifically used for addressing. So we will learn how to subnet IP version 4. I know version 4 is old. It's supposed to go out after 2011, but it's still here and we're still using it in almost all networks, right? We are also going to touch on IP version 6. So we'll take a look at how things are routed using address from your private network into your internet or the public network. And then we'll take a look at how we can segregate our networks into more private area. Let's say if you're setting up a private virtual private network, or even virtual LAN, right? How your subnetting can be used to have some security measure and protection. And then we'll take a look at what IPv6 consists of. So when you take a look at when you're troubleshooting system in case it uses IPv6, you know what part of it is broadcasting, like sending it out to everybody, right? What part of it is part of the prefix? So what is the prefix, right? So we'll dive deeper into that. And then you will have access to actual physical router. I know there's simulator like test out you can use to experiment or configure, right? And I will give you access to that. But what I want is I want you to have the experience on how to really touch and feel the device and configure the device. And you're gonna learn that different models have different commands, right? Cisco try to streamline a lot of that, and then we'll take a look at other appliances outside of Cisco horizon. So we will take a look at how things can get routed. So the router is like a freeway that's going to take you from one town to the next. So anytime that you're sending data from one network to the next network, even to your service provider, right? You need that router. Like at home, you have a wireless router. It is a way that we can transmit, right, or send our data from our home network into our service provider network, and eventually wherever you, like a gaming website that you're trying to access, or YouTube, etc. Right? So we'll talk about how we can set route, okay? How we can look at routing tables and be able to configure that. And then we'll get into the protocols. This is super important because there are certain protocols that are used for certain services, as I mentioned, but some protocols are made for convenience, right? Like UDP, User Datagram Protocol. When you're watching YouTube, you're actually using that. It opens at a rack. So this is why sometimes your video takes longer to actually load, right? Or you're streaming like iHeartRadio, you're using UDP. Compared to TCP, it has to reassemble everything, put everything back together, and present it to you. So it takes a little longer. So some services require specific protocol, right? And we'll touch on the difference between these. And you're gonna see a mix of that in the network as well, okay? And then we're gonna get into DNS. Some of you are familiar with this as you learned that in class. But domain name server, the domain name system is always tied to a web server. So when you're visiting, like, bless you, google.com, youtube.com. So the web server gives you the web content, the page that you see in front of you, the video that you see in front of you. But the domain server is how you get there, right? They register for that domain. So it's tied to a public IP address. And these two always go together when you're looking at, visiting a website or web services, right? And DNS is an area that we looked at in cybersecurity because they can reroute, right? Or transfer your domain into their domain for phishing purposes or other things. So DNS poison is a common technique. So we'll talk a little bit about that. And then in Network Plus, when you take that, there's a huge section on troubleshooting, right? Some of you might be, your focus is in IT, and your job is going to entail how to get systems reconnected, right? When a network stops, everybody stops. No email, no applications, no transactions. I was at the grocery store one time late at night, and I had to wait in line because the sales terminal just halted, right? Can't process a credit card. So they were on the phone, and I'm thinking to myself, simply reboot your system, right? But I didn't say anything, of course. And then the manager got on the phone with tech support, and sure enough, right, they just restart. So sometimes system needs to refresh, right? Its status in the network, and we'll touch a little bit on the technique on how you troubleshoot and ways that you can look at information to see if it's talking, right? Or if it's not talking, how can we see that in command line and troubleshoot through our command line? Any question? Okay, and then we'll get into how we can establish a network, configure our network. So in a couple weeks, we're gonna do a little bit of wireless lab, how to go through and set it up. I'm sure some of you have experience with this as you do that for home or personal purposes. Wireless is such a very common thing these days, right? So as I was teaching in the last 20 years, back then, when a company have a wireless network, that's like rare, right? But now you see that everywhere. You see in a public network, right? If you go to a coffee shop, they have it. Hotel, they have it. Is it safe? Right? That's questionable. But we need to take a look at how we can manage that better, because I teach ethical hacking, so I tell my students a lot of the times from an ethical hacking standpoint, wireless is such an area in the network that's very visible, right? Anybody can drive by the parking lot and scan, like, you turn on your smartphone and look for a wireless access point, you see it because it's always broadcasting, right? So with that, we have to think about how we set it up and how we configure it, and we need to be better at the security area. And then we'll get into dynamic host configuration protocol. DHCP is used in every network. It's a way that we can manage a group of IP addresses. Like when you turn on these computers today, right? You logged into our CCD network to access your email and your canvas. So every time that you do that, right, the system actually acquire an IP address from the pool, and we will learn how to set that up, right? And sometimes we can exclude a certain IP address from the pool. It cannot be obtained by another system. And then we'll talk about how some IP address is going to be permanent. It's exactly the same, and it's the same always, like for your servers. And then some IP addresses for the client system, the computer that you sit at, can be leaks or can be renewed after a period of time, right? So how do we set that up, right? So we'll go through the process of learning how to do that. And then how we can implement a network, and like I mentioned before, right? This is why cybersecurity people still have jobs, because no matter what we do, there's still always going to be imperfection, right? Flaws in the network, because there's no perfect network. But we can start with thinking about the design and the planning of the resources. So when I assess a network, right, I like to talk to their engineer. So when you draw your diagram today for the lab, that's part of the role of an engineer, right? To be able to think about, like, where do I place these things physically? How do I set it up logically? What do I connect that to? And making sure that it is communicating, but at the same time it's safe, right? So that's important. And then, so the network engineer usually talk to the security team or the security engineer and figure out a plan on how to improve, right? We want to be able to grow and also be safe. And so next week we're gonna start making cables. I know some of you have experienced this in another class. You will be required next Friday. I will provide you with the tools and the equipment to make an Ethernet cable and a coaxial cable, because some of you might be doing that as part of your apprenticeship program or your job, right? I have done many cable drops in my lifetime. As I started as a field technician, so my job was at the time to bring in all the systems, right? Connect them and configure them. I have serviced like grocery stores, Coinstar is still around. And then I'll talk a little bit about like how the interface and the application, Redbox, ATM machines, and so on, right? So we will talk about how systems can be physically connected. How is that starting today, right? How is that important in bandwidth, right? Rate, transfer rate. What is the limitations in media? And because we're using copper, and copper can be very noisy, but it's cheap. right? So we'll talk about coaxial, so you will make an Ethernet cable and a coaxial cable. If you're not familiar with coaxial cable, that's a cable that they plug into your cable box, right? It's usually round and thicker, it's like a size of your index finger. And it has a needle in the middle, right? And we'll talk about thin net and thick net today, as far as the different type. And then we'll go into wireless standards when we touch on wireless networks, how to look at encryption type. I think this is really important. We're really tied to like WPA2 or the type of encryption that comes equipped with our wireless router or access point. So what you see is you're gonna have some security measure in that area. And then also frequency and channel. Installing wireless network is a little bit different. Where do you place your AP? So in a campus like this, right? You can't just put your AP wherever you want, okay? It has to be where, so you have to really look at your signal gaps. So there's a way that we can look at, like, you know how when you go to a certain spot and it's really weak, right? So a good wireless network is there's no weak spot, okay? So it has to be overlapping a certain way so there's no gap. So if you have that weak spot, likely that you're gonna need to replan and redesign that part of your wireless network. So we will talk, we'll talk about how we can look at that physically. And then we'll get into the WAN section later, which is wide area network. Old technology is ISDN. I installed frame relay and ISDN for a big part of my early career. That was the thing to go to for a lot of businesses. Communication was slower and it was different back then and expensive, right? But why are we learning the old technology? It's because somewhere in the world, there's still systems or backup lines that are still using old technology, right? Yes.
Okay, I'm not confusing you, but I think I looked at like on the school staff, so like for answers things like that.
Yeah, I taught for technical school, including the RIDE, Western Governor. So that's usually like my academia career. When I first started with my bachelor degree, I contracted with EDS, which is like a global electronic type of installation company, right? So basically, if you have a very large corporation, if you want your stuff to be installed in a new building, you contract with companies like that. So that's how I started. And then I contracted with Orion and a few other companies and some companies that's affiliated with DoD. So on the website, I don't put a lot of the technical things. And on my resume here, I only include a lot of like academia things. But like global insights, there were a lot of contracts that I worked on, and then some contract with the government that I cannot talk about. So, but what I do now is I do mostly consulting for. That's like my morning gig. And so usually I do that on the side. And so hopefully in about when I retire from here, I can also retire from that. But the reason why I stick with it is because once you step into academia, sometimes it's really hard to step back into the game. The industry, the way they look at employment gaps is not very positive. So I have colleagues that have been teaching, right, for a long time, and then they want to come back and they wanted to be like chief information officer, like a CIO. And because you haven't been in the field for so long in this field, if you're not keeping up with it, you're behind, right? So it forces me now to really keep up with it. And what I see from what I do, I try to say, okay, my student kind of need to know how to do this. But the way I teach classes like this, I think about like, if I hire a technician right now, right, what do I want them to have? And so that's how I teach most of my classes, so. Okay, any other questions?
I know like, I didn't say all the videos posted on cameras, I really just trying to keep that. Anyhow, I know you said that to read chapter 1, but you also selected text of that.
Yeah, so I don't require the textbook, the notes. That's gonna be your go-to.
Okay.
All the answers that you see for your assignment is gonna come from your notes. The notes is supplemented with some book material that I had thought that would be useful, and then some other sources like web sources. Because, not all textbooks gonna have perfect information, and sometimes they'll be kind. I don't require a textbook for a reason. It's because you're gonna see standardized network plus books in all different forms, right? But I think if you use the notes, that's gonna give you a lot of the foundation already. So you can read the unit 1 notes. So, yeah, but if you buy the book, just read the book and you have access to the end of the chapter questions. That's gonna also help you review. And then in a few, well, I don't wanna say like around week 8, I will give you access to test out Network Plus or Network Pro course material, and so you can always use that outside of class, and I mainly use it for practice exam, right? So you can use that to prepare for your certification and also do additional practice and learning, right? Similarly, I'm a tactile learner, right? So I like to encourage, like, it's a lot, my students tell me that they remember better if they do things, instead of just clicking through the simulators, sometimes that can be a lot. But, you will have access to that. Okay, so we'll touch on DSL. I know some part of United States still using DSL or satellite if they're in the rural area, only because they don't have access to fiber optic, or other type of media. So today we're gonna learn about network topologies, right? So basically, that's just a layout of your network, how it's physically connecting, how that's different from a logical layout. We'll touch on that. You're gonna draw your home network, right? And then you're gonna draw a small business network based on the list that, so if I give you a bunch of equipment, I'm gonna say, hey, go and plug this together, right? You kind of have to plan out how would you connect this device with that device. So we'll do that on the cloud tool today to really set up your network topology. And then the difference between, how we're connecting it, is it a circular connection? Is it a straight connection like a bus or a ring? Is it gonna be a mesh? So we'll touch on the difference in those. And then we get into LAN and virtual LAN. So from the topology, we can also think about like how you can design a network for your local area network. You're sitting in one right now, right? All of these systems is connecting to a switch. And I'll bring a switch up to show you. And that switch is going to connect to other switches so that way it can send out. It's kind of like, how when you leave your house, right? If I open Google Map and I need to get to Corona, or Norco, right? How do I go about? So you have to go out on the street. So those are your switches, right? And you might need to hop on the freeway. That's your router. So you can leave town, right? And then get off an exit, right? So it gets to the other router and then it's going to bring you back to the street to go to Corona or Norco, right? So the switches is going to bring us across the network, like from this computer to that computer. But the router is gonna bring us from one network to another, from this town to another town, right? From one network to the next network. So we will think about how we can set that up, and it's really mapping the data from where you are to where it's supposed to be or where it's supposed to arrive. And then we're gonna do a little bit of configuration on the layer 4 switch for virtual LAN. Virtual LAN is very popular. We are actually on a virtual LAN. So basically, it is a way that we can group some set of addresses, right? And we can use that as an isolation. It's kind of like one street, how there's some town that would have people that have very expensive private property, right? You don't really have access to that regularly from a public standpoint. They would have private beach, etc., right? So we can set up a private network that way, and we can prevent other people from accessing it. But we simply just use a logical setup in where we would group it to an IP address and ports. And ports are like windows or doors to your home. Things would arrive to the door, like if you want people to come to your house, right, you would bring them to the door, or that's how they exit, right? So we'll come back to that. Any questions? Okay, so once we get through our LAN, we're gonna look at how we would look at your software and hardware tools to things. So there will be exercises that you are gonna use PowerShell, right? Commands in PowerShell, and PowerShell is slightly different than your command prompt in Windows. And then we might also learn that in Linux as well. So we would use also software tool and then hardware tool. So how can we do that when we're troubleshooting? I always tell my students, when you plug things in, look at the lights, right? Look at the LED. If it's green, then it's talking, right? If it's amber, then it's idling, right? Is it actually working? Because that's basic networking, right? And then sometimes people just don't plug in power, right? Oh, I can't connect to the internet. Is your router on, right? So sometimes if you do help desk or tech support, you have to walk people through the troubleshooting part. We will also use protocol analyzer, which is, your network sniffer. So if you use Wireshark before, right, that's a protocol analyzer. In security, we talk about that a lot, right? That's how we can look at what's coming into your network. If you're getting attacked, like denial of service attack, you're going to get a flood from that one source. And you can see that through your network protocol analyzer or your network sniffer. Okay, so we will have exercises based on that. And then we'll take a look at optimizations, quality of service, how we can set that up. So CIA in security, right? Confidentiality, integrity, and availability. The availability part is predominantly about network, right? So ideally, we want our network performance to be up and up. So think about that, right? Like, let's say if you go to Amazon right now and you're trying to make a purchase and nothing goes through, right? If you don't have communication to the web, or their website's not responding, or your transaction cannot be processed, right? Then they don't really have true availability, right? We want the 7/9, the 99.9999%. Is it achievable in most networks? Maybe not. I have some friends that are network administrator, and they tell me my network performance is only at 97% or 92%. So we're gonna have some downtimes, but we have to take a look at how we can optimize that, right? And then we will go into security and authentications. So a big chunk of security is about access. Access is where things can be secured if you have the proper measure, but access can also be where things fall down. And a lot of it comes back to authentication. How you log into system, how system communicates with another system. And this is where you see, right, some access model that's tied to the network that is not effective, right? I mean, it's working, but it's not 100% effective, or it's not giving appropriate security measure. And then we will work on how to set up some of the security appliance. I have Fortinet, so you are going to configure those. They are security appliance, and you can also set up filtering systems on, like, for example, if you want to block a certain service, right? You can set that up, right? You can block it through port numbers. You see that with Windows Firewall now, and so on, okay? Or if I wanted to block a certain physical connection, I can also block a certain port, physical port, okay? And then we will come back to the access, which is authentication, authorization, and accounting. It's supposed to be the quadruple A, but the triple A here, that is really for the access model. Any questions? Okay. And if you just arrived, there was a question earlier about my YouTube playlist for this class. I put it on your course information page at the end. So you can click on that and you can watch all the videos for this class that I have done from this last year and the prior year. And I also have pre-recorded stuff for it when it was mostly online during COVID. And then if you want, you can also watch my other videos from my other classes. So I teach in the horizon of the very intro all the way to the advanced security practices, which is 41D. Okay, so what are you supposed to achieve? We are going to be able to learn all the devices that are reconnecting starting today and the services that for those devices, how we can connect our system to the cloud or the internet, right? And then we're gonna look at how we can troubleshoot the network and also design the network effectively. And then we're gonna look at how the protocols are related to the service and the functionality of that. Okay, now the policy. So advisory, you should take these classes, but you are not required to do that. So if you haven't taken A+, which is CIS 25, I recommend it. And then operating system for CIS 21. I recommend this book. This is to the newer exam, right? You probably have heard or seen that is the 09 now, right? When you watched my prior video, it's probably talk about the 08. So now if you take the 09 this year, you're good for 3 years. You have to keep up your credit. And so that way you can just renew your certification. If you don't, you're gonna have to retake the test after 3 years. So just making sure that you have learning credits. But if you buy this book, it has like practice exam and questions within the book. You don't have to buy the book, but if you want, I recommend the book. Okay, we are gonna do weekly assignments. My lecture is really entail the assignment because throughout my teaching experience, when my students are listening and going over the concept with me, if they're recording the answer in their interpretation of the answer, it helps them remember. So that's my technique. So we're gonna do that. Now, if you miss class, you can turn it in late. Every time it's a week late, it's 10% deducted from your earned score. I like not to take anything above 3 weeks, but in some circumstances, right, just make sure you communicate with me. I'm very flexible. As long as, you know, you let me know what you need and I will try to work with you. So we're gonna have assignments. And then we are going to have a practice exam for your Network Plus. I want you to be ready to take the certification at the end of the class. I will open this around Thanksgiving or right before. So I will give you access to test out and you will activate your license. This is not gonna be due until close to the end of the semester. So you should have like almost 8 weeks, 6 weeks to do it. But my experience, students are gonna wait till the last week. I don't recommend that because you might not get done. Exam for CompTIA is 90 minutes, 90 questions, right? So you just try to practice and making sure that you time yourself. So the higher your score, right, the higher it averaged into your grade. So you can do it as many times as you want. So I will open that halfway through the semester. I don't allow late exam for practice exam and final, okay, for this class. I'm particular about project and exam, specifically because one, I have to get grades in for you so it goes on your transcript in a timely manner. Two, in the industry, if you miss the boat, you miss the boat, you lose your job. So certain things I allow late, but for the stuff at the end, just try to make sure that we do it on time. Okay. Your quizzes, you're gonna have a couple quizzes in this class. They're short and sweet. So if you do your assignments, you can use that for your review. I do have a quiz review game, that extra credit, you can win a gift card. Quiz is due at the Sunday of that week. And then you can just do it multiple times. So the best score out of the 3 is gonna go into Canvas. You're great. And then final exam, I do use Lockdown Browser. This imposed a little bit of problem based on my experience with my online class last summer. If you're using Chromebook, Lockdown is not very friendly with that. You can come on campus to use the computer lab. I'm usually in here for the final weeks, even though there's no students that come there usually. So I opened the final on Monday, and you have until, Thursday, which is the end of the semester, to take your test, right? Do not wait until 10 PM on Thursday, because I get email. Dr. Nguyen, I can't install lockdown browsers, 10 PM, I need to take a test, right? And so try to attempt it before, and in case you run into a problem, you have alternative options, right? Like use your iPad, come to school, find ways to be able to take the test. And it's multiple choice, okay? And it wouldn't entail everything that we learn. For extra credit, you have some opportunity for this quiz review game. And then we'll have some events, because I think October, November, you tend to see more cybersecurity events. So if you attend those, or CSUSB open house, I would allow you to do that. Just take a selfie while you're there, and then submit. So now extra credit is gonna go into the lab area, right? This takes me a little bit of time if I have very big class. So if you miss like a lab, or if you miss an assignment or quiz, something, or like you didn't score that high on the practice exam, I will put some points into that area. So that way it lifts your grade a little bit, but don't expect it to carry you, because I've had students that had really low average in the class, and then they try to do extra credit to pass the class. It's not gonna happen, right? So making sure that, so if you're at the cusp, like if you have 88 and you want an A, right, the extra credit's gonna help you, and no like extra credit. Okay, grading, I use the scale that's standard. Okay, with the college, no pluses or minus. So your quiz is going to be 10% of your grade. Your assignments and participation, your weekly assignments that you complete, and when you come to class, ask questions, participate, 35% of your grade. Lab activities is going to be 20% of your grade. We're going to have about 12 labs. And then network practice exam is 15% of your grade, and your final is 20% of your grade. Okay, I do reserve the right to drop students if I don't see the students for a long time. If you wish to drop the class, make sure you do that by the W deadline, right? Otherwise impacting your financial aid. So if the student missed multiple weeks and I don't hear from the students, I can drop after census. So if you have issues with attendance, just talk to me and we'll see if we can work something out. But I do have a very full class on Monday. I know some of you were trying to add that before. But you can also make up the work if you need. If we have issues, just make sure you talk to me. And then if we need to, we can go through the administrative policy where that can be seen by the deans of student services or academic. And then just do your own work, right? I encourage you to use AI to learn, right? It's great tool if you want to be able to explore something that's not known to you. But for this class, the majority of the things we can address that in our class. If you need help or have questions, let me know. But if the student is cheating, usually it's a 0, and if it's repetitive, it can be dismissal from class. That's a policy for the college as well. Now, if you need a combination like extra time on exam, so some students ask me like, can I have a combination for CompTIA? I've talked to a couple students that went through the process. They went to the lengthy process about documenting it, and they said that it wasn't really met. So in class for quizzes and things, I can accommodate you for that, right? All you have to do is communicate with the ARC. The information is there. You can go to their Zoom or email or call or stop by the center. If it is a course by Moreno Valley College, you have to see Moreno Valley College center. If you are taking classes elsewhere, right, like RCC or NARCO, you have to do so at the other campuses. Here's my contact information. If you call this extension, it goes to my desk. It sends me a voicemail if you leave a voicemail, and I will try to get back to you. The best way to reach me is via email or Canvas message. I usually respond promptly. If not within 24 hours, that's my requirement. And then here are my office hours. So if I have students in my office, I will not be on Zoom, but if you pop on Zoom, it will notify me, okay? Because sometimes students come to my office and they talk about stuff and sometimes it's personal. So due to the privacy, and if I don't have anyone, I will pop on Zoom. So if you have questions, you need help, you can also stop by my office. I'm at the Makerspace, which is in science technology. When you walk in, right, if you veer left, it's next to the wood lab, and you should come by the Makerspace to do things that has cool stuff. And then on Tuesday, I'm virtual only because I have some requirement with the meetings at the campus. And then on Thursday, likely that you will find me in this room on Thursday if you have questions. And then I have other office hours that would relate to my STEM scholarship program and also my chair hours. So if this doesn't work for you, send me an email, okay? And then I'll see what I can accommodate based on the schedule. And that's the contact information. I will respond within 24 hours. Any questions? Okay,
I have a question.
yeah.
Uh,
Go ahead.
but at the end of the course, should we be able to take that class here on TI?
The Network Plus,
Yes.
yeah, yeah. So that's the goal for a lot of these classes, like the CIS-25, you're supposed to be able to take the A plus. But based on my experience, it's really the individual, right? Like if you continue to learn and you prepare for the exam, then you're ready to go. For example, I taught CIS-27 last semester, and 3 of my students passed the certification the week before the course end. And I gave them the voucher and they passed flying colors, right? And then the Network Plus, I had a couple students from last year that passed it. But the majority of the students, they wanted to spend more time studying. And I can't speak to everybody, right? Like, ideally, I would encourage you to take the test. If you don't take the exam by the end, right, and you wanted to take it maybe a month later, 2 months later, that's fine, right? But if it's fresh in your mind, it's probably best, right? That's what a lot of the students tell me is that I wanted to do it now before I forget all the material. And that way, I can move on to the next class. So,
And for that test, you need a voucher?
yeah, so if you're Moreno Valley College, you're in the apprenticeship program, just email me. And I have voucher for use.
That was the question.
Yeah, so we have voucher for A plus, Network Plus, Security Plus. Currently CYSA, but that's being changed to another certification pretty soon. Pen Test Plus for ethical hacking class or ethical hacking students. We currently don't have anything for forensic, but we do have like CASP, which is for CIS-41D. As you move along, I see that a lot of the students, they focus on the entry level, so they take a lot of beginning certification and they don't continue to take other certifications, but as you know, right now, the industry requires 3 or more certifications. So they always tell you, like, at first 2, now it's 3, soon it's competitive, right? So look at the areas that you want to get into. If you want to be an ethical hacker, take the Pen Test Plus, right? If you want to start security, at least Security Plus and CYSA now. You can't just get into the security area with just Security Plus anymore.
If you want to do like networking, like what's the best certification thing?
Network Plus, right?
Yeah.
And then if you want to do Cisco-based certification, CCNA. RCC teaches CIS-26 series for CCNA. Now, I didn't have CCNA. I'm gonna tell you straight up, right? I had Microsoft certifications and that's what got my foot in the door. I eventually went back and got the Network Plus and the other certifications, and when we took it a long time ago, it grandfathered in, so we didn't have to renew. But some of the security certification now, the way I look at it is like, is it really worth $1,200, right? Because they're expensive as you move in a higher, like CISSP, they're pricey. And you can't just take the test, you have to get validation of your work experience and referral and all of these other things. So, but think about the area that you want to get into. Network Plus is probably a good start. But if you wanted to just, if you're new in this, A plus, network plus, security plus, those are the three that normally the students go for. Okay. Other questions? Okay, and I think I have a page on Canvas, so if you go to here it talks about like how you can get the information, right? And then if you're interested in like counseling or a partnership, we can also go to the page. Okay. Other questions relating to syllabus? All right, let's get into the nit and grit of things. So we're gonna roll with, so I like you to download and open Unit 1 notes along with your assignment. So we'll go to those two together. And I'll explain the notes about leveraging that and along with the assignment. So we'll go through. This is kind of like a long assignment, but we'll get through it. Okay. And if you didn't pick up a USB because you came in later, right? I have an extra USB up here with a lanyard, so you can get one. It's yours to keep. Just make sure you take it with you when you leave. A lot of times students always ask me like, well, did you find my USB? Just make sure that you take it with you. Because sometimes the other comes in here. Right? Not find it in, it's not missing. Usually they get it turned back. You're welcome. Now the computers here, once it's shut down, all your data is wiped. So make sure if you need to save something, put it on your USB or your OneDrive. Because they have it wiped up on restart or shutdown. Okay, so the first part of the notes, it begins with talking about what will be considered a network. So a network would be any two systems connected, right? So if I'm airdropping my image, my picture that I have taken, right, and share that with my friend who has the other iPhone, that's a way of two systems communicating. When you're at home, you are connecting your laptop and your PC or your smart TV together, you have a network. Now, there are different types of network, right? But anytime you have two or more systems together, and that's considered a network. Back in the day, long, long ago, right, before most of you were born or even your parents, right, the way that we shared resources like data is to put it on a floppy, and then they call it the sneaker net. You put on your shoes and you run it to the other computer. Those days are long gone, right? We don't do that anymore because now we have ways to interconnect. Ultimately, the goal of the network is to be able to share resources, like files, like applications. So, and in this picture, you see that everything is labeled as hosts. So a host could be a computer or it could be any system, right? It could be a PC, it could be a tablet, right? So a host is just a system and the system can connect to another system and that this system is connected to the printer based on the design here. So going to your assignment, for the first question, it asks you, what is a network? And you don't have to write verbatim, right? You can also clip it from the notes and add it. You can summarize it however you want to do that. If you want to handwrite the answer and, scan it and submit it, that's fine too, right? As long as I can read it, that's great. Okay. So as we define, a network is two or more systems connected. Okay. It could be thousands of systems connecting, or it could be just a few. Now, the goal in the network is to share resources such as your data, your information. And that's the main point in networking is for us to be able to share. So for example, right, I'm able to share my document with you for the assignment, via the cloud network, right? And then also the RCCB network, so you're able to download it. So it's a way that we can share resources, and sometimes it doesn't have to be data, right? But the majority of the time, data is just an object that we create using the computing system. So now, in this process, when we are connecting the devices together, we're establishing what we call a local area network, right? Your LAN. So when you see the acronym LAN, that stands for local area network. So what does that mean? It means that it is a system that is pertaining to that physical location. Like this particular school, you're sitting in a LAN right now, right? But if you go to, let's say, a high school, that's a different LAN, right? That's the LAN for that high school. So every network is going to start with the local area network. It's pertaining to that physical location. Now, leaving that network, like I said, just leaving that town, right? You have to hop on the freeway. You have to leave it through using a router. So the router is a system that's connecting one LAN with another LAN, right? But inside the LAN, you're gonna have a switch. And it looks like this, right? So each of the connection point, that's what we call a physical port. And your Ethernet cable will be plugged in here. So if I connect this system with that system, I plug the cable from that system to a port and the next system to the next port, right? And I might have the full connection if I have many systems. But if I don't have enough, what I can also do is I can configure the switch to turn off that port. So if someone walks by, they cannot just plug their computer, right? A rogue system, and that becomes a security problem. So this is the catalyst, and then this switch is then going to connect to other switches, right? So that way we would have the larger span of the network. And when you connect a bridge, a switch to a switch, that's called a bridge. We bridge the device together. That means that you're connecting the same devices across, right? And ultimately, there will be a switch in the closet or at RCCB office. And that switch is going to connect to the router, and that's how it routes your data from here to youtube.com, right? Or Canvas, etc. Okay. Any questions?
Question.
Sure.
So is this heavy LAN switch?
So, not necessarily. If you're looking at wireless LAN to VLAN, they don't necessarily have a switch. So to go home right now, you have a LAN, no switch, right? You have a SOHO, which is your small office home network, right? But if you look at your wireless router, in the back, there's physical connection too, right? You can plug your PC into the Ethernet port. So it functions as multiple roles. Your wireless router also functions as a firewall. So basically for home, the industry, the companies is, oh, you know, we're gonna produce an appliance that has multiple capabilities, right? But if you're looking at corporate infrastructure, yeah, you're gonna see switches. If you go to AWS data center, right, Amazon, where they house all your domains for cloud, yeah, you're gonna have switches. So the majority of the time, you're gonna see switches being used to interconnect the system within. It's kind of like the roads that we go from, one house to another, right? But if you need to go from one town to another, you have to hop on the highway, the freeway, right? In other states, there might be just a highway. You have to leave that town through a highway or freeway, that's the route. Okay. So an example of a LAN would be your business network, a school network, right? And it would consist of computers, systems, printers, servers. That's if you're looking at a business, they use these devices for the operation of the business. Like I might need to print invoices or receipts, right? So if you go to the grocery store, That's a network already, right? If you do a self-checkout, that's a system that connects to their network like at Walmart. Okay, and it prints out, it has a printer, it prints out the receipt, it might not look like your regular desktop printer. But you have a printer that prints out those receipts, right? It's a thermal printer if you're studying for A+. And then you might have mobile devices, that's common. So mobile devices needs to be connected to wireless access point or wireless router, right? Later on, when we draw, we have to think about that, okay? Mobile devices, some of them can connect to the physical cable. My laptop doesn't have an Ethernet connection, right? All the newer laptops don't have Ethernet connection. You have to connect it wirelessly. So if I wanted to plug a cable into it, I have to buy an adapter for it, right? So, so not all mobile devices have a way that you can connect a cable to it. Okay. So another type of network that you see as you read through the notes is going to be a work group. Work group is a terminology that's kind of older, but it's still around. In Windows environment, when you configure a network for a Windows system to talk to another Windows system, you might see this term comes up. So a work group doesn't really have a lot of security measure, and it tends to be more on like where I would connect or as a physical connection one system to the next. And we're going to touch a little bit on peer-to-peer, right? So a work group, when you connect, let's say I want to connect one PC with another PC and maybe the second PC to a third PC, that can be also a work group. But when you're looking at that level, it's actually the computers are equivalent in role, right? There's no hierarchy, there's no server that's controlling computers. So therefore, you tend to have the lack of security. If you ever connect to the wireless network, it's going to tell you, do you want to be discovered, right? You see that little prompt on the Windows PC? Well, if you say yes, and if someone's trying, so let's say I connect my laptop to my home network, and I'm on my desktop, and I'm trying to get files from my laptop, right? I don't want to go over there, put on a USB, right? Or I don't want to upload it to OneDrive and then download it from there. I want to direct connect. So once my PC is discoverable, I can use my desktop to connect to my laptop. But I need to have access to it. I have to authenticate to it. I have to have its password, right? To be able to access its resource. So the only way that we can control the security is from one system to the next. But beyond that, right, you can't, right? So if you have 1,000 system and if you put it on work group, guess what happens? It's a lot of work. It's granular to control that 1,000 system, right? So we have to find a centralized point to be able to control. That means that we have to have a server, okay? A server is a centralized system that we can control everything else that's connected to it, okay? So sometimes you would see this for like department work groups. So I might have like a small real estate office, right? And they all have laptops, and for the sales agent, right? So I might just have them connect, but not recommended, but you can. They just connect the devices together and it works, right? So home network, you do see some of that too. Now, some of you have more very advanced home network. I talk to students and I'm amazed all the time. Like they're like, oh, I have a media server, right? I have stuff that I use for games, so some home networks are more advanced than other, but if you just turn on your wireless router, connect a couple appliances like your tablet, your laptop, and maybe your smart TV to it, right? So technically, it's all equivalent in the role, and it is on a work group environment. Question? Okay. Now, when we leave our home network now, right, we're entering into the cloud, right? So when we draw the internet as a cloud, that's basically someone else's network, right? Your internet service provider. It could be Spectrum, it could be Frontier, it could be AT&T, right? So when we leave our home network after our router, we're gonna enter into someone else's network, and that's considered a wide area network, your WAN. So that just means that it's in another location and it's connecting to your system via the router. Now, you can use this private or publicly. A lot of the times when I talk about ethical hacking, I said you're coming from the public, that's the internet, right? Anybody can connect to the internet. Right? Anybody can see your public IP. So your public IP is like an address that the world sees, right? Every website has it. So if they have the public IP, they can possibly maybe ping it to that, or they can try to connect to your system. But that public IP can be used for hosting domains, right? Like your google.com or youtube.com. So it can be used multiple ways. Okay. Now, when you look at a distributed WAN, it is a way that we can interconnect, right, the system in different places. Think about this. When you go to a bank, right? You go to an ATM, let's say Bank of America, you drive up, you withdraw some money, right? Your information updates their system, right? And let's say you go to another location later that day, withdraw some more money, it updates, right? So technically, they're using interconnection across the internet to be able to have separate physical location LAN through WAN, right? But Bank of America, their corporate office is in Texas, right? So it is a way that we can interconnect through WAN and be able to distribute the same information for the system, the ATM machine that you access. Understand? So you have many branches, many locations, and it could be worldwide. How am I gonna go from Texas to maybe Brazil, right? You might be able to withdraw some money at their local bank, but it updates Bank of America, right, through the WAN, right? So now, what you see is you're able to scale with the distributed WAN, right? So if you're corporate, like you start to see, I sometimes like when I'm bored, I would watch videos and it would say, people would go to Costco in like Japan, and that's interesting to me, right? But Costco, as you know, they're based out of Washington, right? So to expand globally, you have to interconnect via the WAN this way, right? You are gonna be in Japan now and it needs to communicate with their corporate office to inventory purposes, employment, HR, et cetera, et cetera. Okay. It's at the end of the page, so what I'll do is I'll move C down to the next page so we can see the next part together. And then let's move this up. Okay, so for 3, right? And when you look at the notes, as you scroll down, right, we talked about this, and it gives you additional diagram and the comparisons and it goes into peer-to-peer, and we touched on that already, okay? So the notes is just more details if you want to read more about it. And we talked about the server, which is the system, but one important thing I want to point out, server hardware is different than your regular system. Can I make my gaming computer into server? Sure, right? You're gonna see later when we look up server hardware, you're gonna be like, oh, my gaming computer is probably faster than that, right? Sometimes that happens. But server, its job is to provide services to anything that's connected to it, right? Like, so you are logging on to maybe a file server to access your drive for OneDrive, for OneDrive to be able to download your files, or email for school, right? Okay, let's answer 3. Okay, so let's talk a little bit about the difference between intranet and extranet, and when you see this, okay? I think a lot of times people get confused between these two. Intranet is a way that we can share information, tools, applications within the organization. So for example, when you're using portal to register for class, right? It is a way that only RTCD students can access that portal, and it would have the application that you need to register for class. And it would tie to the database that contain your grades, your, it would check for prerequisite, et cetera, with through the application, right? So the outsiders don't access it, right? I can't go to RCCD portal for students because I'm not in the student group, right? JV's college student cannot access RCCD portal, right? So it's really pertaining to that group of users for that organization, okay? So that means that the systems that are offering these services, it's really comprised of access for that, right? Sometimes you do see like remote access that will fall into this area where, let's say I work 50% remote from home as a network administrator, right? I can interconnect with the internet, but when I log in, it's gonna take me to my desktop. And then we'll configure remote access down the line. In your extranet, this is, it would be owned by the company's network, right? But it's really intended for external people to access. For example, I'm gonna take a case of Starbucks, right? You know, Starbucks sells coffee or drinks, Starbucks now just for beverages. But in order to have the operation, they're gonna buy cups, sugar, all the supplies that they need, and they need to connect to their partners or their vendors, right? Who provide them with all the resources, all the supplies, part of the supply chain, right? So that means that when they update their inventory, there has to be an application through their database somehow to be able to communicate with their vendors, right? And when you see, sometimes they would have multiple vendors for the like the same type of product. For example, like coffee cups can be coming from, let's say, Dixie or whoever makes it. But then they also have different sizes of coffee cup. Plastic cups is going to come from another company, etc. Right? A way that we can streamline this is to provide an extranet. It is through, again, a web interface where they can log in, and then it's going to take them to specific system that would allow them to have access for inventory purposes, like a database, right? So if I'm low on coffee cups, my vendors would automatically know that they need to ship me more coffee cups, right? So now here it says extranet is often, right, or similar to what you see with demilitarized zones. That in the DMZ, basically you're gonna have these systems that are gonna be connecting to the internet directly, right? And we tend not to have too much sensitive data in the system. Sometimes you might have some type of messaging or email, also databases, to be able to allow access for the external individual or users or systems. We should protect the DMZ, and that this goes into another class. So often you would see a firewall, a physical firewall, or an application firewall sitting there. But when we draw it, it is basically an additional part of our network that is public facing, or it's facing the internet, right? Compared to our local area network, which is, has to contain private information and so in order to go from the extranet into our network, right, it has to bypass through a physical firewall coming in after the route or before. So I'll show you some of that later. Okay, we talked about systems and then we get into a workstation. So a workstation is a computer, right? So if you ever look up the hardware, like if you want to buy a workstation from HP or Dell or IBM, right? You tend to see that the workstation price is higher than your regular consumer PC. It's really made for long-term usage. So the lifetime of the system in most organizations with the regular use is how long? About
4 years.
about 4 or 5 years, right? Ideally, we would cycle through about 5 years. But if you have extensive use, that might be a little shorter, right? So the workstation is really system for the employees. And that means that it's regularly used. Now, can I build a PC and make it a workstation? As long as your hardware accommodates that, right? But usually workstation is just a label that they label for business-based PC. And then we get into the server. So these are some of the roles of the server, and it's not only limited to this, right? You're gonna see more additional server, but you're gonna have file server. So file server, Microsoft called this now storage and file server role. So your system out of the box, I just got rid of a big giant server that was in this room that's given to me by the IT because they were just taking up room. But the hardware that you see on the server, when you look at it later, that was part of the class in the next few steps, it's going to be a little bit different, right? The motherboard is going to accommodate processing, and the processor is also different. Often, if you're looking at Intel, it would use a processor specifically for heavy duty processing because you're gonna have thousands of requests at once, maybe, right? Or millions in the case if you're looking at social media companies. Okay. So let's think about like Meta or Facebook, right? Or Instagram. How many users are uploading pictures and videos this instant, right? Around the world, right? So it needs to have a way to be able to categorize. So all of that goes into a database though. But it's all the files, the JPEG, the MP4, all of the videos, even if you're looking at TikTok, same, right? It goes into a server and it would relate that object to the subject and be able to pull it anytime you want to look at your old picture or your family wants to look at your video or picture, right? So we have to find a way to centralize the storage of the files and distribute that files to the people who want to have access to it. Okay. And in the company, you're gonna have a lot of data, right? That's money. Data is money, and data, that's what we have to protect. So the system, hardware-wise, same, but you're gonna give it a role. So all of these servers are just functions that the system takes on to provide you the service, understand? So sometimes you're gonna see a system that functions as many roles. It's kind of like human. You are a student, but you are also an employee somewhere, maybe, right? You might be a parent. So the way that we build computer system is really we build to resemble the human, right? To take on the roles that maybe possibly that we can't do, and this is what we see with AI. So file server, store and dispense file. You can upload and download files to share. Mail server, Microsoft uses Microsoft Exchange. This is what you use for R68. The majority of the company uses Microsoft Exchange, right? And then if it's not Microsoft, it's just an Exchange server. So this is a way that it can circulate your mail in external and internal, and it handles the email pertaining to the inbox for the user account. Okay. Now, if you are, for those of you, I think some of you took my forensic class already, I see. But in forensic, when we look at that, from the time that you send your mail to the time that your mail is received, there are many servers in between that handle your mail. It's kind of like, how you send a package, right, from here to maybe New York. you know that there's gonna be a lot of post office, right, in between, and it's the same. So you're gonna have a lot of different mail servers so when we do forensic, we follow that, right? We look at the header, we see who handles the mail, where does that come from, right? How did things change, etc. Okay, your print server, this allows you to manage printing document. Now, this might be important for companies because they want to control resources. Can I make my computer into a print server? Sure, right? A print server would have the driver of the printers that you are using, right? So I might have 100 printers in my facility. That server is going to be able to have the driver. So in the case if system A connects to the network and wants to print from printer 4, right? It's able to do that through the print server. So now you can also control like how much you want to print, what kind, which segment of the network can print. Like for example, in this room, we can only print from that printer, right? But then I can't print to the library, for example. So I can control it through the print server. Now, you don't have to have a server hardware to handle this, but in a larger scale, you should. You can also set up a print server with just like a computer, right? But most company in a corporate environment, they wouldn't use the print server, or any server roles and having to accommodate it with the hardware. We talked about a little bit about web before. So web server, its job is to give you web content. HTML, okay? The page that you see, the video that and then JavaScript or whatever the application that they would use programming language. So on the web server, you're gonna see folders that would have all the code, right? For the applications and for the pages that you see for the web itself. Now, in order for the web to work in the internet scale, right? We talked about the domain, the DNS before. Fax server. I know you're like, who fax these days, right? California requires what signature? That means that some contract you have to sign with a pen. Like for example, if you ever experience financing a vehicle, a house, right? Up on agreeing, buying that and owing a certain amount of money for it, you sign, right? And then they have a record of it. Same thing with mortgage, right? You sign for a house or your parents do that. Now they use that to fax. So for lending companies, banks, they require that, right? You go to auto dealerships, you're gonna see that they have that. So that way, if let's say I go and I buy a Ford, I might borrow from a certain bank. I sign the paperwork saying I owe $30,000 for this car, right? That gets faxed to the lender that I agree on this date. Some state require wet signature and some don't, right? So in certain states, you cannot digitally sign because they want to validate who you are. There's a witness that signs, same thing. So contractual wise, you see companies that have fax server. Then your application server. These are a way that we can control what applications is used on the system. For example, I want all the system to only use a certain browser like Chrome, right? Or Firefox, for example. I can push it through application server. You see this in all networks. From like school district all the way to auto dealership, etc. So this could be used for like controlling finance application, who has access to which application, and so on. And then telephone server, this is for call center. So it can route to the direct line, or like, when you call that tech support, right, to get help or complain about your bill, that gets routed to the right area. But telephone and server actually been around even in school. You ever been to school where they have announcements to call students? I live right near an elementary school and I can hear their announcement every morning, like, please report to principal office, right? Myself, I did service some of the telephony server in that kind of environment in the old phone. But you do see some old system and new system this way. Now, from a networking standpoint, a lot of the data center that's more advanced now uses voice over IP network, in their network, which uses the higher layer switch. We'll talk about different switches, okay? And then your proxy server, those of you who are interested in security, I hear students like, oh, I create a reverse proxy, right? So proxy server can be used in many different ways. It can be used to direct traffic. So you know how in grade school, you can't just go to any website, like in high school. You can't just type in like even YouTube, sometimes they block. So they set up a proxy server to filter out the connection. To block and unblock. It can also be a traffic cop. You know how when you have a detour, right? There might be someone guiding you to that route. So what we can do is we can set up proxy to say, okay, maybe for all the finance systems, because it's priority in this company, we're gonna set it up to go to this proxy. And then everybody else to go to another proxy. So we can direct traffic that way. Okay. Okay. 4 to 5 hosts. So we talked about what's a host. It could be any system. It could be a laptop. It could be a tablet. It could be a server. Point of sales, which is POS. It could be an appliance like a firewall, right? I didn't put it on the list, but. Okay. So a host simply is just a system. Okay. And I highlighted this because I want to mention that, all hosts communicate on TCP/IP network, right? Which stands for Transmission Control Protocol and Internet Protocol. That means that they have to have address to communicate, and they have to use some type of protocol, some type of rules for the communication under this suite. Kind of like, how everybody in a certain region or country speak the same language, right? It might have different dialects. Like if you go to the South, their dialect is a little bit different compared to Californians, right? But we in the United States, predominantly we speak English, and then you also have people who are from different ethnic, they might, but we agree on a language that to be spoken in that country, right? And also written languages, right? So the system is the same, because remember, we built it to resemble us, so there's the set of rules that were created for the system. Okay, so we're gonna research the type of systems that we're using, right? So first, you're gonna start with the router, and don't use the wireless router. So open up your Chrome or Edge or any browser of your choice. I'm gonna use Chrome, and I'm gonna go to Google, and I'm gonna search for router. And of course, it's gonna give you a lot of the wireless router, right? You can also search for like Cisco router if you're interested in Cisco router. Okay. So I'm gonna pick this one. Now, if you look at the router, right? It's different than a switch, isn't it? The switch, because its job is to connect all the system inside, you're gonna have more physical connection for it, right? Remember the router, its job is to do what? It's a transit system, right? So it's transfer your communication in and out. So it's only gonna have a few connections depending on the router. Some are for fiber, some, depending on how old or new. So it's just gonna be connecting to the line, right? That's gonna transfer for transit purposes in and out. Okay, so that's different. Now that could be varied in price depending on where you look at, the model, how old. Okay. Or you can also find others. And some might come with like Ethernet port. Let me see if I can find FS. Yeah, if you have additional connection like this, you gotta read it carefully because sometimes they are something else. See, like this one is a firewall, right? And this is actually cheap for a Fortinet, because you can see like, how they are varied in security appliances are kind of pricey. Some of them can go up to $100-something thousand. So, but if you're searching for a router, you might see like this one is a Cisco router, right? That one might be affordable for a small business. Or sometime you can go bigger. But the most important thing I want to point out is make sure you read the description because the accommodation for the router, the service that you can configuration that you can have on that router is to its spec. Not all routers are created equal, right? Even if in the same grade, right? Like if you're looking at small business routers, some of them don't, you can't do certain things with it. So you want to make sure that you select the right one, but you can pick anything you want for our assignments. I just want you to kind of see what it looks like. Okay, and then we can find the next one, which is a managed switch. So this one is a managed switch, right? And you can see it will say a managed switch, right? For example, this one is a 24 port PoE smart managed switch. So what does it mean when it's managed and it's not managed? Managed is configurable. That means that you can go inside its operating system and change things and add things, right? Whatever the service that's available on it. An unmanaged switch, you just plug it in and use it, but you can't really change anything about it. Okay. So in a larger network, we would have a managed switch. Now you have 24 ports for 24 systems, right? So in this room has 50 computers. How many of those switches do I need? At least 3, right? So you're gonna, 2 is only 48. So you're gonna have 2 extra. Now I can also do one of these, the 48 port and a 24, right? So it depends on the engineer on how they want and how much money they want to spend ultimately, financial speaking. But you're like, wait, the Aruba is so much more. So the feature that you have on the Aruba is different, right? Some switch are meant for data center, which has a lot more feature compared to some switch that's meant for a larger scale lane, a smaller scale lane. Understand? So you got to look at the spec. Right? This is also from FS, but you see, and then you also have like, oh, this is a layer 3 switch. That means anytime that you see layer 3, that means it can function as a router. Okay, so it can route and switch. So that's why it's a little more, right? So we will learn about the layers later on. Question? Okay, so pick one of the managed switch that you want to, and you put the link in there. I just want you to learn how to be able to find them. And then if we find an unmanaged switch, and they tend to be cheaper. So do I need to connect all of these computers on a managed switch? Not necessarily, right? Some companies do because they want to control who's connected, right? So For example, at the bank, I might, because I wanna be able to control the ATM that's connecting to the switch in that range, right? Because the ATM on the outside, it has to be connected with the inside systems as well, right? Because that's how, if you go to the ATM, withdraw the money, right, you go inside, they can override some of the stuff with the inside of the ATM machine too, so. But an unmanaged switch, you just plug the cable in and the systems in and they communicate, right? But this is better than a hub, why? Because a switch, it knows when your data doesn't get there. So if I send some data from this computer to that computer and it doesn't communicate, right? The switch has a record of it, where a hub, it doesn't care whether it gets there or not. We don't really use a hub anymore. Okay. Now, you do see the smaller switches. So in a segment, if you have like a room that only has, let's say 12 computers, you can get the 16 port or the 18 port. Okay. Then you have access point. So let me ask you, is access point the same as your wireless router? Some people, they're like, oh, find an access point, right? Get on my access point. At home, your wireless router is your access point. It's all in one. But in an environment, like a business environment, like the school here, access point is access point, right? Because if I drive out to the parking lot, I can still connect to the RCC. How? RCCB network, because there's access point, but all the access point has the same SSID, right? For that wireless network. So wireless router sometimes is not an access point. In some cases, it's the all-in-one device. But in a business environment, access point is access point, okay? And all mobile devices need to be connected to an access point or a wireless router, okay? So if you don't have that, you're gonna have to add it, okay? So you can find one, and like I said before, right? If you see one higher in price, look at the type of feature, the things that it accommodates. Some access point function as also firewall. Just like your home router does that. Meraki is also popular. You have Cisco, they're all different brands. So when you get Cisco certification, it's to Cisco technology. Microsoft certification is to the vendor. Can you manage other devices? Sure, there's some similarity, like Fortinet, they're gonna use some same, like similar command, but not exactly the same, so you can figure it out. But some vendor, they don't use the same structure. So, it's helpful maybe because they see your skill sets, but you don't have to certify to the vendor. Okay, so find the access point. And then server. So I'm just gonna narrow down maybe an HP server. You can also get Dell server. Now, some servers you see, they're like a tower, right? So this you can place in the server room at the tower. But if you want to put it on a rack, when I was speaking at the portable, then we had racks in the back. So we can horizontally mounting it onto the rack. And this is what you see in most server rooms, they are rack type server. And so, but let's pick one and so you can see the spec a little bit. So let's say I'm gonna go with I'm gonna go with this ProLiant. So it's gonna say it's rack mountable, so you can mount it, you can bolt it onto the rack, right? And let's look at the spec. Okay, so this one has 64 gig of RAM. Okay, it's hot swap. You guys know what hot swap means? That when the system's still on, you can unplug the drive, and then this is common in data center because, if you look at that, like data center for social media, they only have a certain amount of time for the tech to get to that drive, right? So if the user upload a picture and if it's not storing and if you don't swap it fast enough, right? You have down on that system, the storage is not, it's not recording that file, right? You're in trouble. So they only have a certain amount of time to do a hot swap. Okay, but hot swap simply is that I can replace the drive while it's on and it's a 3.5A, right? So it runs on SATA, so hard drive and solid state. And you see that the processor is going to be a Xeon, but you're like, wait, it's not benchmarking as fast as my gaming system, because your gaming system might be close to 5 gigs, right? But this is what you see normally with the one Xeon. And some server can accommodate multiple processor, the board, right? So it uses gigabit Ethernet, and you tend to have multiple network interface card on the board from most of the server motherboard. Okay. So, and then some server, if you see the cheaper server, you're gonna see that it's actually like as slow as a slow computer, like a 1.8 gigahertz. On Monday, I showed them that, right? So when you are renting a server with AWS or using the free AWS account, when you read the spec, they're gonna give you 4 gig of RAM, right? They're gonna give you like a slow processor type of server. Now, if you want faster response in your system, you're gonna have to upgrade your cost package, right? You pay for what you get, simple. It's like if you want to drive a sport car, buy a sport car, right? You cannot buy a compact and expect to drive like a sport car. That's how it is. And in the tech world, it's the same way. Okay. So if you pay for minimal, if you use free stuff, it's gonna be slow. Okay. Okay, so we got all the stuff, just put the URLs in the list. And then let's talk about network device that you can use for WAN. Okay, anytime that you enter into someone else's network, remember where I said you need a router. But earlier you saw that I clicked on a switch that is, I looked at the switch that has layer 3 or 4. So anytime in the OSI layer 3 is for routing. Okay. And if you have a switch that can route, it can function as a router, then you can use it. You also need a gateway. And the gateway sometimes, most of the time, it is your router. Just think about like how when you leave your home, right? Let's say if you have a gate, you have to exit from the gate, right? And come in from the gate. So gateway just means that it's a system that allows you to have traffic coming in and traffic coming out. And often that they are the same as your router, okay? And then in a peer-to-peer environment, you have all the system equivalent in the role. Meaning that a system is, you can only control the security of that system for the next system to access. There's no centralized server to be able to control. So in that, if you have a server, then it is a server client environment. So a home network is a good example for a peer-to-peer network. Internet cafe is a good example for that. When you're using public Wi-Fi, right? Which is similar to what you see with the wireless for your home network. What you have is your systems are totally enrolled. And be careful with public Wi-Fi. Okay. And we're halfway there. We're gonna get going a little bit better. So for 10. So when I draw my network topology, how is it different from physical and logical? Okay. Network topology is a way that we can look at how your data or your system is connecting. And in a logical way, we can look at how the data flow from one system to the next. So a physical topology is really a physical arrangement of how your system is connected. Like how this role, each of your role where you're sitting at, right, the computer is gonna connect to the physical port that in the wall, and inside the wall or through the wall, it's gonna then be connected to the switch. So it's really pertains to the physical layout of the room. Okay? So, you know, I was in here a couple weeks before summer and they were talking about maybe rearranging the desk. And so that way we can fit more desks in the room. Well, we can't. Without having to move more network drops or drill, right? In this room, we have a fault ceiling, right? What you see on top is not actually a ceiling. And they run electrical cable and communication cable through the fault ceiling. Some places, like at the data center, you're gonna have a raised floor, right? You have a floor and a subfloor. So there's a real floor, and then on top of it, they would have a subfloor, so they're gonna run the cable between the two floors, right? So it's a way that we can control the actual cable, so that way people don't get hurt. Also, right, physical security is important, because if I want to disconnect your network, what do? Cut your cable, right? So in 2011, when I was teaching a class, I think it was a Microsoft class, there was outages across the country for like the whole day. Sometimes you see this on the news, right? Half of the country go out because a service provider just lost their connection. But that day, someone had went down to the manhole and cut the fiber connection for, I think it's Cox or one of the larger provider across the nation. And it took out most of the larger networks, right? Because they're using that main line to distribute. So even when you're looking at Spectrum or even like T-Mobile and AT&T, there's affiliation with these companies that they use each other's network, right? So when they cut the cable, you got outages, right? So in the case of physical, it's really pertaining to the arrangement and the actual physical connection. But then the topology, it really delineates or it shows how the system, the data goes from one system to the rest of the network or the next system. Sometimes they're exactly the same, right? But there are times that they are different. Okay. So the engineer, they're gonna give you, if you want to look at the physical topology, how things are physically connected, that's that. But if you want, like in security, a lot of the time we look at the logical topology on like, you know, so it draws like the servers, right, on the racks, or all the servers combined from different offices. It might be on one drawing, right, and they would label it. So because it's not physically separated, right, so it's a logical topology. Sometimes they combine different area systems together on that drawing to kind of show you, oh, this server passed the data to the next server, even though it's like Texas to Minnesota. Okay. Okay. The content of this class is heavy, so hang in there. I know it's a lot, right? First day. And this chapter is kind of overviewing all the things that we are going to dive deeper into. So there will be chapters that we will touch a lot more on each area. Okay, so the advantages and the disadvantages of a bus topology. So simple bus topology. If I take computer 1 and I connect it to a computer 2, and that computer 2 connect to computer 3, and it's just straight down the line. Well, in your role, it's not a bus topology, it's a star topology, right? But back in the day, that's how we were connecting. Okay. Now, sometimes that could be to a physical connection. Bus is not very common anymore. The downside of bus is that there's lack of administration. So if computer 2 is down, computer 1 cannot talk to computer 3, right? If the middle one is down, that's it. You're gonna have a single point failure, like I said, right? You can't really control because one computer to the next. And you don't have a fault tolerance, because if the middle ones are down, I'm done, right? To build tolerance, and you're gonna have to add computer 1, connect it back to computer 4, computer 1 connected to computer 2, and it comes more financially higher. More cost. So in security, we want a way that we can administer multiple systems repeatedly. And we want to move away from single point failure and have fault tolerance. So if you want fault tolerance, you're gonna have a mesh. They are interconnecting multiple ways. But that is more cable, more network adapter, right? More cost. So bus is not advantageous. But if you just connecting it initially, it can be low cost. I argue this though, right? If you're looking at other areas that's deficient, it might be more in cost if you need to granularly administer it. Now, if you have a star topology, when do you see a star topology? At home. Your wireless router is the central point to everything, right? In the middle. Your laptop connects to it, your tablet connects to it, your TV connects to it. And you can add more. So if I go out and I buy, I don't know, another laptop, I can connect to it, right? Easy. Now, physically, if we connect the cable to it, it won't bring down the entire network. So I'm going to ask you the same question I asked my Monday class. What is the maximum number of devices you can add to your home wireless network? Let's say if I win the Powerball the end of this week and I just want to go crazy, right? I want to buy many systems. What's the maximum number of devices you can add to your wireless network? 99. 255. Huh? I guess you guys are thinking about like binary numbers.
56.
Huh?
56.
Higher.
Higher?
Higher than 99.
So,
256. Someone said 255. It's 127. Ideally, most wireless router will handle 125 to 127. But what will happen is the more you add to it, what happens? That centralized point gets bogged, right? And the delay of the networking, we call that latency. It's kind of like, you know, at home, you're that one person that everybody relies on. And if all of these people ask questions continuously, you won't be able to respond as quick as possible. So, Instar, relatively easy to troubleshoot. If you don't have internet connection, check your wireless router, right? Or your system. Disadvantages. Total installation of cost could be higher, so the more you add to it, the more it's going to increase, of course. You do have a single point failure because if I want to take you down, I just have to attack your wireless router. I flood it. Your wireless router is always going to broadcast its SSID. I see what it is, right? So how can I flood the system? Just continuously asking it to respond. Okay, so single point failure, we talked about that. So that means what? A good reliable network cannot just have one router to route everything, correct? So if you are looking at a corporate environment, if you're relying on one router, it's going to be, everybody's going to be very slow, right? If you have thousands and thousands of systems. So that means that you're going to have many different routers connected. And they would share the job. It's kind of like having multiple freeway, right? To be able to travel on to get from point A to point B or one town to the next. And then we can also control like which router handles what. Okay. So star topology is not ideal. So in today's world, sometimes you would see a ring ring is not too common. A lot of times you see mesh, like I said, mesh is a way that we can interconnect. So system one, right, is gonna connect to 2, 3, 4, but then it's gonna, interconnect back. So you're gonna be drawing multiple lines back to that system. So if I have one server that's serving 5 different systems, right? It's gonna distribute out hierarchy, but then the system itself is gonna then interconnect to other systems. So one, I would go across, I would go up, I would go horizontally, and so on. So a mesh is a way that we can have multiple connect to the same system across the network. Now that can be costly, like I said, but it gives us fault tolerance and redundancy. A ring is exactly what it sounds, right? You take a bus and you loop it back. So if I go 1, 2, 3, 4, and that 4 is gonna come back to 1. The good side about it is the 2 in the middle. If it's down, I can still communicate system 1 through 4, right? But again, right, we're gonna have to reconnect it back, so it's looping back. Okay. So when you have point-to-point topology, you might have a computer to a computer, a computer to a switch, a computer to a router. That's a terminal. We use that to configure a router. A point-to-point topology simply it's just that, a host to a host, right? I could have a switch to a switch. So when you connect the same devices across, like a switch to a switch, a router to a router, we call that bridging. You guys know if I have let's say a PC and I want to connect to another PC, can I connect it with an Ethernet cable?
Yeah.
What kind of Ethernet? Not a regular Ethernet cable. We will find out next week. So your regular Ethernet cable that you buy is called a straight through cable. Okay, it passes and the way it's wired is straight through. You cannot connect the same devices on a straight through cable. Okay, it's just the way the signal has to communicate. So when you have a computer to a computer, you have to connect using a crossover Ethernet cable. You will make one next week. Okay, but if you connecting a straight through cable, don't expect it to call. Yes, I'm sorry.
Are they mostly cross through? Like you can hit them out like they sound close.
So yeah, you can buy a crossover cable.
But they usually cross over. Like,
No. So when you go on Amazon, you're looking for Ethernet cable, it's gonna give you a straight through cable. It's just the wire on how it crosses when they assemble the connector is different, right? So if you connect the same devices and keep that in mind, right? When you do a switch to a switch using an Ethernet, so we can make a crossover cable. If you want, you can do a straight through cable, but yeah, straight through is your standards are different. Your connector sets up different. Okay. Oh, sorry. That's just another example. You don't have to put that switch to a router. Okay, let's look at 15 and 16. An example of point to multiple point topology, right? You can have a router to multiple routers, like what I mentioned before, right? You want to be able to have multiple routers in your network so that way they can distribute the work and have more performance. You can have a switch to multiple computers. It doesn't have to be 5, it could be 24, right? So you span out from one system and you can connect to multiple systems. So, but if you design a network, you always want to think about how you can grow your network, right? You don't want to just design it just for that many systems. So if I'm adding, I have to know a way that, like, yeah, if I design, I might be able to add more switch a few years from now. I might be able to add more computers to my switches. So you got to make sure that you plan and scale for 3 to 5 years. 16, what should you consider when you create a network design or topology? Business rule, money, okay? In IT, we love to add a box and add more boxes to it and connect them together. That's what we do, right? But ultimately, that, the cost doesn't just come from installation, it comes from maintenance too. So you have to consider, because cable goes bad, right? You have to reinstall or, system might be bad, so you have to replace, so cost. Ease of installation, how hard is it gonna install, right? The price might look really good because, you see from the website, they're always trying to sell you the product. Is it easy to configure? Is it easy to manage? Is it easy to install? So the maintenance, the installation is important. And then make sure that you have fault tolerance. Fault tolerance just means that you have an alternate way to connect or interconnect. So that's gonna come back to our limitation with cost, right? And then security. Okay. So campus area network, oops. Sorry. This about 10 more and we'll be done. So your CAN, now these things come up on Network Plus and your certification exam and also our quiz and our final. So I want to make sure I cover all of this for you. So when you're looking at like a campus, like a college or a university campus, you're gonna have buildings, right? You're going to set up a way that their systems can communicate, like a college, like this. But in a lot of places, in businesses, they also call their facility campuses. Like if you ever been to Cisco, right? If you go in San Jose, Cisco span over like multiple blocks on the street, and they're all their buildings. Same thing with Google, right? You've got that whole section of town that belongs to the company. And so it's kind of like a university or college campus, where you would have buildings and you have to connect them together. So, if you guys know, if I want to connect this building to humanities, what kind of cable do I use? Can I run an Ethernet cable? Can I run a coaxial cable? Or do I use fiber optic? So the next question you should ask is how far is the building, right? Because cable have limitation with length, right? Some buildings is really far, right? Like I was at UC Berkeley, going from their engineering building to another new building that they have for like data science that was like 20 minutes walk uphill, right? So that kind of narrowed down, okay, what kind of cable, and then we said, what kind of transfer rate do you want, right? But ultimately, we don't do Ethernet outside of the floor itself, right? Even from one floor to the next, we should use fiber optics. Especially when you have a lot of users and systems connecting. So one building to the next is gonna be, nowadays, is gonna be fiber optic, okay? So it talks about connecting the buildings together. Now, you probably have seen this before or heard of it, storage area network. This is also known as SAN, SAN. So basically, it is a way that we can distribute data. We can have this integrated into the networks, right? It simply is a system that can function as your storage server if you want, but can function as a way that we can manage our data storage, okay? They can be expensive depending on how much data you want. And you can use it to manage. And some people, if they have the money, they would get this for like their media server. I have a friend that set this up And what he does, he has his own Netflix, right? So he uploaded all the old DVDs and the Blu-ray, and he can just access the movies from home or remotely, just logging onto that server and watching it anywhere, right? So it really depends on how much you want for storage and all of that, but media server tends to pick up a lot of storage, so. So you can have a collection of data that way, you can stream. Okay. Any questions? And you can also find like systems that's affordable. It doesn't have to be super expensive, but you do see that they are high in price. 19. When we make our coaxial cable next week, right? We are gonna use the thicknet, okay? But there are two types in the coaxial, as I described there, the round cable, right? Often you see them black or white, and they have the needle in the middle, okay? Now, the thin net is the older technology, okay? And they use the connector that it uses is called RG58. I just brought the connectors. I left it in my office because I was gonna bring it next week, but. Okay. Now, the newer one, which is the thick net, it uses the RG60. Okay, which is an upgrade from that. So the difference between these two, one, the thin net is smaller, right? It uses different connector. So your diameter is slightly different, right? But if you look at the old houses, like if you go visit your grandparents or someone who have the older cable, when you compare, they look really close, right? And as I was telling also the Monday class, right? When you see that number 10, right? That 10 base 2, that number in front of the word base is always going to pertain to transfer rate, right? So when you look at 10, that really represents 10 megabits per second. Okay. So if you're looking at other type of cable like fiber optic, it might be at 1,000 or 1,000, right? Megabit per second, which is now your gig. Okay, so anytime that you deal with Ethernet, you're always gonna have IEEE 802.3. I know this is on the network. 802.3 classification is for Ethernet. Okay. So whenever you see 802.3, you always think about, oh, that's Ethernet. 802.11, that's always wireless. Okay. And there's different classification for the IEEE standards. So the thin net and the thick net, the thin net was a base 2, and the thick net is a base 5. Okay. The big advantage for the thick net is that it runs longer, 1,600 feet. This is why they use it for cable TV. It's cheap, right? You can have 100 stations to connect it to a vampire tap. So I live in Moreno Valley, right? I am like how the city, my neighborhood is not up and up neighborhood. And when you drive on the street, you see this green little box, like it's a little tower like this big, right? And I always see my neighborhood, someone's tampering with it. It's always kept open. Did you know that when you open that, ever watch the service technician that comes out, they adjust the throughput rate at that box, okay? So technically, your bandwidth is actually shared with all the houses right to that box, okay? So if you ever look at your cable, it goes from your house has a D mark. Usually it's in the garage somewhere, right? So if you run your cable, let's say that I have a living room, I would run it into the D mark. And that D mark is gonna drop into the ground, it goes to the clean box. And that clean box goes into the bigger chute in the manhole. And then some highways, on the highway, they cover this, you don't see access to it, but you see this little green or brown covering, And when you lift that up, you have access to specific service provider manifold, right? There's a stair that flows down, and that's where they control the resources for the section of the town, right? But as we know that it is not monopolized, so Spectrum or Frontier would own a certain part, right? And then they have specific manifold for their 5G drop. I see Moreno Valley is expanding, so whenever I drive to work, I always see those truck with the big rolls, right? And the technician, they service, so they roll for the new neighborhood. So the average going rate for fiber optic technician is $50 an hour. And if you're interested in that certification, let me know, I can show you some resources to obtain that. Okay, so we understand the difference between ThinNet and ThickNet, 10 base 5 and 10 base 2, right? They're still throughput the same, but what you can, you have the distance that's different. So the newer cable, this is how you're able to span out, and they use it for cable TV still. So I have fiber optics so called in my neighborhood. We paid for that, but then I asked myself, they say it's fiber optic because the main line on in the street in the manhole is fiber optic. But from my house, the V-Mark to the box is still a coaxial, right? So I'm really buying a sport car, but I can only drive it at like maybe 70 miles per hour. But anyways, unless like they replace everything, all the infrastructure along with the homes. So the newer homes are built with the fiber optic. That's true fiber optic, right? To the wall. Okay. All right. So STP. STP stands for shielded twisted pair, right? Your Ethernet cable is a twisted pair. When you cut it open next week, like, you know, when you unwrap the cover, the plastic cover, you see the twisting together. You have to untwist them and arrange them to what we want as crossover or straight through, right? But the STP, the shielded twisted pair, when you cut open the coat before the twisted copper, you see a little foil wrap. This foil wrap, what its job is to prevent signal leak, right? You guys heard of EMI? So that creates interference. All cable has some kind of noise. All your electrical components, your computer, everybody, right? Like they say, use enough electronics and microwave, right? All of these devices have some kind of signal, okay? So when you have a bunch of cables together, like in our server room, you're gonna have interference from one cable to the next. So if you buy an STP, that reduces the interference. You understand? And they are higher in price. So when you buy cable, let's say you go on Amazon, you buy a quick Ethernet cable because you want to run it from one room to the next, right? You are gonna get an unshielded twisted pair, a UTP. Because most of the time, the common one is a UTP. The STP is often used for like server room or where you have a bunch of cables together. Can you use it for home? Sure, right? It just costs more and it does do its job in protecting signal leak. Okay. So what kind of cable do you see that has STP? And I think the coaxial we use also have that. So when you cut it open, you're gonna see a little foil, right? A 10 base T, 100 base TX, and 1000 base TX. Okay. So like I said, the number in front of the base means the speed. And then whenever you see TX, that represents fiber optic. Okay, so now let's get into some of the cabling. So when you make your Ethernet cable, you're gonna find that all the cables that they sell is either Cat 5e or Cat 6. There's Cat 7 now, but it's not that popular. Cat 5e is in most networks today, right? Cat 5 been around since, I don't know, forever. I've been teaching for a while and my students have been making Cat 5 for a long time. Cat 5e is the later version of it. Now, Cat 6 and Cat 5 use the same connector, but Cat 6 cable is faster, okay? So can you use them interchangeably? Yes, you can. Most networks, they might already have Cat 5e, and if they want to add Cat 6, it's going to give it better throughput. It's just a faster way to transfer. So the frequency that you see, frequency in computing really talks, it's basically represents speed for us, right? So the frequency you see is going to be 100 hertz to 250 hertz. What's the frequency for your monitor? Who knows A plus well?
This one is 300, yeah.
Yeah, but if your standard monitor is below that, right? 60 to 100 something. So the higher the frequency the monitor, the better it is for your eye, right? So if you buy a really high grade monitor, yeah, like he said, like these Alienware monitor, you can check the spec for it. But you see electrical components, you're gonna have like different frequency and the range of the frequency. Okay. Any question? So if you go further down on the notes, it also gets into the depth of your, like here, it goes into the twisted pair, the difference, okay? And then UTP, like what I said before. And now we're going to talk a little bit more about, so here's the net, how I asked you the question earlier. So if you connect the same devices, the computer to computer, switch to switch, you need to use a crossover, the signal across differently, okay? Which is this, okay? All right, now we're gonna get into the fiber optic portion of the exercise. Let me move this down. Okay, so fibers are different. You got the single mode and a multi-mode. So SMF stands for a single mode fiber optic cable, and MMF stands for multi-mode. And this is long, and you can grab this from that section of the notes. So what's the difference? Let's see if I think we're good with 21, right? The single mode, you are going to have high speed and long distance, okay? And inside it, you would see that it uses LEDs and sometimes laser. Now, fiber doesn't have to be used for communication. If you ever own audio systems, some of them come with fiber cable, like home theater system, stuff like that, right? And you don't have to write everything there. I'm just very descriptive, so you can just summarize. Now, the installation of fiber for the single mode is a little harder than the multi-mode, right? Bless you. It is beneficial to use single mode if you want faster data rate, okay? It is 50 times, actually, I'm sorry, distance. It's faster and distant. So it's 50 times farther. You send it farther. And it is faster than the multi-mode. Okay. Now the multi-mode, the way the signal light is created, it uses a core and reflection. They are all glass packed. Okay. Fiber uses glass, it's glass core. So this is why when you install fiber, you have to splice it and it has to be straight. When you cut it, right? So if it's off by a little bit, your reflection, if it's a multi-mode, is off. Okay. It's kind of like aiming a laser, right? You want it to aim straight to hit that core because it's fiber to fiber. But if you are not straight, if you are off by even a millimeter, right? It's not good. Right, so So there's a technique in splice, but now we have tools and equipment that is very precise. Back in the day, there's a handheld I actually donated to college of the desert when I taught there, because I had a bunch of equipment. And you would line it up, kind of like with a handgun, but you line it up, and that's how you splice it. But now you have systems that have electronic systems that is actually really precise, so the cutting of it is a lot easier. Okay, so on the multi-mode, what we want is, it's also high speed, but the distance is only gonna be up to 3,000 feet. This is why we say that it should be used building to building, right? And so if you want to go like campus-based network, multi-mode is probably ideal. But it can be used for other area, right? And then the multi-mode, it also have like a plastic version of it, but for flexibility. You know, so what you see is you see that the consumer fiber optic cable is the plastic version of that. Versus the industrial cable, when you see those truck with the big rolls in the back, right? Those, if they're doing multi-mode, that's like plastic. Okay. So keep in mind, if you want to go further distance, we want to go single mode. So I told this story to the Monday class, I just make it real quick. Google got a tax lift when they opened in San Francisco or Mountain View. San Francisco said, we'll give you a tax break for 10 years. And then after, you know, the company was doing well, then they realized that they have to pay tax for the expansion of Google, for how they are, right? Google had decided that they wanted to be able to save some money for tax, so they wanted to have facilities on open water in San Francisco Bay has open water area. So they put things on ship and, you know, like systems, data center. And in order to have their system communicated, they run fiber tunnel to the open water. And you do have people who own islands, like they're very expensive rich people, right? They own expensive land out in the middle of the ocean. Yeah, fibers ran through the tunnel into the ocean to their island, so that way they can have access, right? So you see single mode being used for that. Question? Okay, so where can I find this information on the notes, right? You can also use the navigation bar, right? I just select the navigation bar on my dock, and then you can go to the fiber optic section. You can find single mode and multi-mode right here. That's on page like 16. I don't include everything on the Q&A. This is something that, you know, I thought that will be important for you to know as a IT person, or, you know. Okay. So FDP, just basically a fiber distribution panel. There are pictures of it on the notes. It is a way that we can terminate the cable to that box, right? It has a tray and a splice drawer. Remember what I said, how you splice, make sure it's straight and it's connected. And so if you have like a central office, a remote office, land that use fiber optic, you use that. When I was teaching at TSC 16, we have a fiber box installed there, and I would point your students to it. It looks like a huge square cable or rectangular cable box, and then you would see the fiber terminate to that. But I think I added some picture for you to look at. So that's a PDF. Or I'm sorry, FDP. A PDF, FDP. Almost done. A few more to go. And then we'll take a break. And then the lab is not very long. It probably take you less than 50 minutes to do. So you will get it done. And if you don't, you can also finish it at home. Okay. Any question regarding fiber? Okay, so let's talk about BPL or broadband over power line. Some places in the world, right, or even in the United States, they don't have communication or networking lines like what we would imagine. They would use power line for communications. So there are ways that we would be able to utilize this, having just the type of electrical power connection, the wiring, and it is operating at a higher frequency, so that way you're able to send data along with receiving power. Okay. Remember that all the communication media, ultimately it is an electrical wire, right? And when it operates at different frequency, that's how we're able to utilize it for different functionality. So in the radio spectrum, it's able to allow the people to use it over the air for communication services. So you might sometime travel to a certain part of the world that use this, or see a facility that has this. Not too common, but it is used. And my videos are on there, so if you, from prior year, and also my recorded, right? I have a page for the video. So if you want to, you can always go back, and I will try to post this video by tomorrow, if not tonight. So you have it, okay? So the important thing to highlight for BPL is that you gotta make sure that you address the interference, right? Like we talked about before, we always gonna have electromagnetic interference, which is EMI. Especially if it's in higher frequency, you gotta make sure that there's less interference. We cannot do 100%. Fiber optic is one of the best ones to have no interference, but if you're dealing with electrical wire, copper base, that you're gonna have interference, right? And interference, what's the consequences of that? You're gonna have, degradation in data quality, right? Signal loss, maybe miscommunication or interruption. So ultimately, it's that. Question? Okay, I'm gonna move 24 down so I can give you access to the next few. Some of you already finished that part. Okay. Is that okay? Because I know you probably finished the other. Okay. So, I always touch back on this. So in other classes, you might see the iteration of this. I know it's in, switching and routing. Sometime in A+, it talks about CSM, ACD, and CA, and I'm sure network plus in variation, you're gonna see the question comes up. So this stands for carrier sense multiple access collision detection. Our system, so your information or your data, your packets collide, right? So it's like bumping into each other, and potentially that can create problem. So what you would see is that we built a flight system with some form of mechanism that allows us to, one, detect potential collision. Two, right, is another way to completely avoid it, right? Analogy of this is, no matter what happens every day on the 215-91 freeway, there's gonna be accidents. Our leading to costs. Well, we can have a way that we can detect, right, potential accidents so that way they can avoid possibly fatality and other things, right, damage. So in order to really have transmission that is more accurate and effective. In Ethernet technology, what we see is that this mechanism allows you to detect collision, right? In the case that it already occurred, that allows you to be able to resolve the collision. So I know that this is long. Again, you don't have to write verbatim. You can go to that section of the notes, which is following the fiber, and you can find the information on this. So when it's detected, it's gonna stop the transmission. And basically think of a frame is a way that it can reference. So it's gonna transmit a jam signal. It's like a notification. And it's gonna resend that frame. So this is how a lot of the switch is functioning using CSMA-CD is that once it's detected, potentially if it's not right, you're gonna have lots of data. So it's gonna stop sending and then resend once it's detected. Okay, so that way you have assurance of data. Okay, otherwise you're gonna have data loss. Now, avoidance, which is the other one. Okay, so it talks about here, this has been used since the 90s, as you can see. Avoidance, sorry, did I move too fast? Avoidance is a way that we can completely avoid the collision. So when it starts to send, right? And if it sends something that's in idle, it's gonna transmit and it's gonna retransmit again for the entirety. So basically, it's a way that instead of collision happening, it's gonna avoid it completely. Okay, this is an upgrade from the CD. This came later. And it is important and it was integrated for a lot of the wireless devices because the wireless device, as you know, the signal can be inconsistent because it's passing through the air. And so what you see is the transceiver and the transmitter is able to look at the packet. And then if it's unreliable, then it's going to reestablish that, right? So it's just completely avoided if it sends that it's unreliable. So that's a better approach than having a collision already and then having to retransmit. It's kind of like, having a car accident already and then redriving the car in a better way, right? Yeah, just resending that car down. Well, we wanted to avoid it completely in the first place. Okay, so this operates at layer 2. That means it's a switch operation only. Okay. And it's for the frame. So we'll talk a little bit more about a switch. We'll have a whole chapter on that. So data link layer, this is going to be for frame and switch. Okay, almost there, just a little more and then, okay. The types of modulation, and you see this already if you're listening to the radio, you got AM, FM, and PM. These are the modulation. And the breakdown for that, we can go back to the notes. Okay, 27. What type of cable is used in 1000 base LX? Right? Now you notice that I told you earlier 802.3, right? With the Z, that's really made for fiber optic. This is the addition, but this was for the Ethernet, right? But 802.3Z, this is for fiber optic. Anytime you see the X at the end, right? So this is 1000 base LX. So 1000 megabit per second. base LX means it's fiber optic. So this is a single mode fiber SMF. Yes, you have to know this stuff for network class. It's a lot of details, but what I recommend is go back and then just familiarize yourself with the standard, right, and the type. Just like how A+, you have to know like the pin sizes and all of these things, even for legacy technology, old technology. Question? Okay, so we talked about modulation, and then lastly, describe the purpose of Network Information Service, NIS. So this is a way that we can use a directory service protocol. So we can distribute data and configuration file from through the network. And we would do this. So I teach a Python for networking, and you can automate it this way. And this is what the industry is using. So that means that I have a server, all my system is connected to my server. And at one point, what I can do is I can write a script, right? And I can reconfigure all the systems that are connected. It could be all the switches, right? All the routers through that script. And it's because if you have 300 switches, you don't want to manually go to one by one and then go load up your iOS and then go in and configure it manually. Nobody wants to do that. I mean, if you want to get paid by the hour to do that, but you're gonna hate it after like the tank, right? So what we can do is we can automate it, and this is a protocol that we can use, right? Under this type of service that I can set up the configuration, right, in an automated way, as long as I connect all the systems together. And it's convenient and it's easy to manage, right? So at 2 a.m. in the morning, and they call you and they're like, 16 of the switches are down. Somehow maybe it got flood or there's storm, right? And it was, or maybe misconfigured by another technician. You don't want to drive to work and having to do that. You need to remote into the centralized system, and then you can just set it up, right? And then you call someone and say, hey, you need to reboot, right? Because after you update, after restart, so to speak, such the new configuration. So life is easier that way. Okay. So my advice for you in this industry, you also need to learn a lot about Python and scripting, right? I know that we have part of that program, the class is part of the program. That's important. All right, let's take about 5-7 minutes break, bathroom, water, snacks, and then we'll come and finish up with our lab demonstration and we'll call it a day. And I'll take attendance when you come back from break. I'll stop the recording.